Good evening, students, and welcome to this live Ahaguru session. This is part of the JEE Mains crash course. Okay, so today is the first class for mathematics, and I think the overall crash course structure would have been explained to you. We are going to have a worksheet. In mathematics, at least I'm going to give you 10 questions. Then we are going to have a test that follows the class. That's a practice test with about 5 questions. Okay. And then we also give you a homework sheet which will have about 10 questions. So you will have at least about 25 questions in each chapter. Okay. In addition to that, of course, all the other questions that you've done so far, etc., will also be useful. Okay. In my class, whatever I give, most of these are, in fact, most of these are previous year questions from JEE Main. In some cases, one or two maybe from JEE Advanced, but that's easy questions earlier that used to come in JEE Advanced. Okay, not recent ones that are slightly more tricky. But the other thing is, I also give a summary of a chapter. Now, one thing that many people should not do is just rely on this summary alone. In fact, I think Balaji sir has already told you that creating your own summary sheet is very important. In fact, what I would like you to do is to compare what you have created with what I've given and see if you can modify your thing if necessary and add and whatever you feel is important and this thing, right? So do not just rely on what I'm giving alone. That's not a good idea, because whatever you make, you will remember better. Okay. So the way I do this thing is I will very quickly go over the theory, meaning I will just mention some of the key points. Okay. So subsets, sets. Okay. These are some key ideas related to sets and subsets. Okay. Properties of operations is very important. Okay. Distributive law. Then the important thing is union is distributive over intersection. This is something that many times you don't apply. Okay. Then De Morgan's laws. Okay. Then some basic ideas and some things related to N of A union B, A union B union C, etc. Now, the next idea is Cartesian product, which is simply A cross B, okay, which is ordered pairs A comma B. Then a relation is a subset of the Cartesian product X cross Y. Okay, actually, let me do one thing. Let's go ahead and do the worksheet. So I've tried both. But relation comes in the very first. So functions we'll do a little later. Let's just do sets and relations. Let's go over the theory because those are easy. Okay. A relation is a subset from X to Y is a subset of X cross Y. Okay. Then reflexive, symmetric, transitive. This is very important. These questions are very common in JEE Main. Okay. Then domain of the relation is the set of all first elements. Okay. Range of a relation is the set of all second elements. Okay. I don't know why we didn't write that. Second components of elements of R. Okay. I hope these are basic ideas about sets and relation. Now, normally what we do is we give this summary one day before the crash course so that you have some time to go over it. See, most of the questions generally are related to functions. Okay. So that's actually, maybe I should not postpone that. Let me go over the theory for functions alone. Functions also. Functions definition is a function is a relation where there is a unique image for every a in the domain. And f plus g of x is f of x plus g of x, etc. K times f of x is k f of x. So these are all fairly intuitive. The only thing is domain of f by g. If you divide two functions, it excludes situations where g of x is 0. Okay, so and composition of functions g of f of x is g o f of x. Okay, then domain and range of some common functions. Okay, you have polynomial where it is defined over all real numbers. Range is a subset of real numbers. Exponential, again all real numbers. Range is only positive real numbers. Even 0 is not allowed because e power no number can become 0. Okay, you may think minus infinity, but minus infinity is not a real number. Logarithmic function is defined only for positive x, not even 0. 0 to infinity or r plus. Okay, and the range is all possible real numbers. Modulus function, you know. Okay, these are very common functions. Domain is all real numbers, range is r plus. Greatest integer function, domain is r, range is set of integers. Okay, I should have probably put z, sometimes that's confusing. This is, then you have special categories of trigonometric functions. Trigonometric functions, whole category by itself, where domain of sin x and cos x is all real numbers, but for tan x, it's all real numbers minus odd multiples of pi by 2. For cot x, all real numbers minus multiples of pi. For secant x, odd multiples of pi by 2 not allowed. Again, cosecant x, odd multiples of pi not allowed. And the range is all real numbers for tan x and cot x, minus 1 to 1 for sin x and cos x. And for secant x and cosecant x, mod is always greater than or equal to 1. Keep that in mind. Okay. Then odd and even functions. Okay. A function is odd if f of minus x is minus f of x. Okay. And most important is most functions are neither odd nor even. Okay, so if you just take some simple polynomial, f of x is equal to x squared minus 3x plus 7. This is neither odd nor even. It's not necessary that all functions will fall under either odd or even. Both odd as well as even are very special small subcategories. Periodic function means f of x plus t is equal to f of x, okay, for some number t, which is called the period. And lastly, this is what we keep getting again and again: injective, surjective, and bijective functions. Injective is one-to-one, surjective is onto, bijective means both, one-to-one and onto. And if a function is bijective, then we say that it has an inverse. Okay, a function, if you have f and g such that f of g of x is x, so inverse is defined using composition of functions, and g of f of x equals x, then f is the inverse of g and g is the inverse of f. And we say that this is possible only if f is bijective, and the inverse is g from b to a. And one important thing in this is that when inverse exists, it doesn't mean that a and b have to be the same sets. A can be all real numbers, b can be all integers, and still inverse can exist. Okay, now let me just take that back. Let me take that statement back. There are other possible scenarios where the sets are not equal, where the inverse can exist. With real numbers and integers, that's a little tricky. Okay, and then the last point what we have said is if a function is injective but not surjective, that means the range, which is say b1 is a proper subset of the codomain, then the range is not equal to codomain. But if you make the codomain as b1, the function can be made invertible. So that means a new function f1, which is a to b1, will be invertible if it is injective at the first place. These are some ideas related to injective, surjective, etc. Okay, so these are the key things in functions. Okay, if you have any clarification or doubt in the theory, you can proceed to go ahead and ask now, because but don't ask me to derive anything from scratch. That is going to be very time consuming. Please go ahead and do question 1. Okay, so if you don't have any questions, go ahead with question 1. See, the theory thing, I have not covered the theory. I know I just sort of breeze through. This is just so that you sort of get in touch or contact with the theory. You look at it and say, oh, this is what it is, right? Hopefully you did that already before the class. Okay, so let's go ahead and start with question 1. And also, if you have any doubts, okay. In the past, I've tried to give 2 problems at a time, um, and then asked everybody to answer both instead of one question. But here, yeah, when it comes to functions, when we come to functions, I might give you 2 questions at a time. For now, let's do 1 at a time. Okay, you do have a few doubts. So while you are solving the question, let me answer the doubts. Anushri Balaji, can you explain the line below the greatest integer function in the summary? Okay, what I've said is x minus greatest integer x is denoted by curly brackets x. This is what you are asking, Anushri Balaji. This is fractional part of x. So for example, greatest integer 3.7 is 3. Fractional part of 3.7 is 0.7. So x minus greatest integer x is fractional part of x. 3.7 minus 3 is 0.7. So if you take minus 4.2, greatest integer is minus 5. Okay. X minus greatest integer x is minus 4.2 minus 5 minus 4.2 plus 5, which is 0.8. So fractional part of x is 0.8 of minus 4.2. So fractional part of x is always greater than or equal to 0 and less than 1. Even for negative x, the fractional part, see for minus 4.2, fractional part is not minus 0.2. Fractional part is defined as x minus greatest integer x, which is always positive by definition. Okay. TT Vibhav has asked, can you give an intuitive thing for how to find number of one-to-one functions from and onto functions? I think there is a question like that. When we come to that question, we will address that. TT Vibhav. Okay. Then Ayush Visha, I find functions tricky. What should I do to improve it? Whatever we are doing is, the purpose is to improve it only. Okay. So do not worry, this will help you. Okay. If you feel particularly not confident about a particular topic, do some extra questions about that in the homework, etc. Make sure that you do functions questions, because that will force you to get comfortable with the topic. Vishwajit, can you define what is an equivalence class? I don't believe that. See, if a relation is reflexive, symmetric, and transitive, it's an equivalence relation. And equivalence relation, if you know, it's enough. Equivalence relations give rise to equivalence classes. Okay, but that part I don't believe is there for your okay. So it's a group of elements which are equivalent to each other. So that is what equivalence classes are. But if that is there, they will tell you separately. Okay. Then Kaushik Raj has asked, can you explain second point, 11th subdivision about symmetric difference of two sets? Okay. A delta B is the symmetric difference is equal to A minus B union B minus A. It's called symmetric difference because A delta B is B delta A. And this is A intersection B bar union B intersection A bar. A minus B is nothing but A intersection B bar. That is the difference of two sets. That is also there in your A minus B is there as item number 9. So that is what is symmetric difference. Okay. I hope this is clear. Okay. Now, many people have given the correct answer to this question. Just give me 1 second. Okay. So for this question, I've given too much time because I was answering the doubts. Okay. Okay, so B minus C in this question is there is B intersection C bar or B intersection C bar, whichever notation is convenient to you. Now, what is the set B? Set B is numbers of the form 3k plus 1. So 4, 3 into 1 plus 1, 3 into 2 plus 1, 3 into 3 plus 1. So you can see that it is 4, 7, 10, 13, etc. Okay, and C is all even numbers 2, 4, 6, 8, 10, 12, etc. So B intersection C bar is take elements from C and cancel them in B. So cancel 4, all the even numbers 10, 16, etc. Okay, so what will be left? So B intersection C bar will be all the odd numbers in B. Seventh, and clearly you can see there's a pattern here. This is of the form 6k plus 1. Okay. Okay, now what is set A? Okay, n square is less than or equal to n plus 10,000. Okay, now clearly n equals 1 will satisfy, n equals 2, 3, etc. will satisfy. You can solve it as a quadratic, but it's terribly inefficient to do that. You can see that around the boundary of where n square becomes close to 10,000, we may have to check. For example, n equals 99. Is 99 square less than or equal to 99 plus 10,000? Of course, yes, because 99 square itself is less than 10,000. What about n equals 100? Yes. Now the key question is n equals 101, 102, etc. So let's check for 101. Is 101 square less than or equal to 101 plus 10,000? So this is easy to check. 101 square plus is 100 plus 1 the whole square, which is 10,000 plus 1 plus 200. So clearly this is wrong. So for 101 square itself, it doesn't apply, means 102, 103, etc. It is not going to apply. So A is simply the set 1 to 100. Okay, so what is A intersection B minus C? All the elements in B intersection C bar till 100. So A intersection B minus C is 7, 13, 19, etc. all the way till 97, because that will be the last element in this. Now this is an AP. Okay, how many are there? This is 6 into 1 plus 1. This is 6 into 16 plus 1. So n of, so let's say that this is S. N of S is 16. So the sum is 16 by 2 into 7 plus 97. 8 into 104, which is 832. Okay, quite a few people have got the right answer. Very good, because it's not a multiple choice, it's a fill in the blank, so it's tricky to get the right answer. Okay, if you finish the question, you can move on to the next and need not wait for me. Okay, go ahead with question 2. If you want to know which is the trickiest question in this worksheet, I'd probably say question 3. Earlier, I used to put those trickiest questions in the end, but then many students felt that easy question I can solve, tricky questions you solve in class. So if you want to know the trickiest or challenge question, I mean, not in terms of just guessing an answer, but like doing it properly, that's question 3, undoubtedly. Okay, right now question 2, again it's not the same relation everywhere. First is mod of x minus y, second is mod x minus mod y, third is mod of mod x minus mod y, and fourth is mod of x minus y. So first and fourth, same relation. So whatever idea you apply can be used for both. Okay, apologies for the glitch in between. There was a net problem, just having to switch to different net. Okay, but anyway, I was just anyway waiting for students to finish. Okay, by now quite a few people have got the right answer for question 2. Okay, so I have explained this during the theory. For reflexive, you can check for each element in set A. For symmetric and transitive, what I have said in class, and this is very important, by default, all relations are symmetric and transitive unless there is a violation, and it is your job to see if you can find a violation. Symmetric and transitive are not proved by definition, it's proved by the violation. By default, it is symmetric. This is something that I mentioned in the class because that's the idea that we are going to use. Okay, so and the question again, by the way, is which of the following is not a correct not correct. Okay, so first, mod of x minus y is reflexive and symmetric. Mod of x minus x is less than or equal to 1? Yes. If mod of x minus y less than or equal to 1, mod of y minus 1 less than or equal to 1? Yes. That is what symmetric demands. So that means this is a correct statement. This is not the final answer. This is a correct statement. We want to know which is the wrong statement. Okay. Let's look at option B. Mod x minus mod y less than or equal to 1. Okay. Actually, what I should have done is I should have written the function first and then check the condition. So first is mod of x minus y is less than or equal to 1. Okay, so this is the function for which we are checking. The next is this function. Okay, mod x minus mod y is less than or equal to 1. But here we have to check reflexive but not symmetric. So this is reflexive and symmetric check. Reflexive check is mod x minus mod x is less than or equal to 1. Correct. Symmetric check is if mod x minus mod y less than or equal to 1, mod y minus mod x less than or equal to 1. Clearly this is wrong. You can take some simple case. Okay, mod 5 minus mod 3 less than or equal to, sorry. Mod 3 minus mod 5 is less than or equal to 1 is correct. But mod 5 minus thing is wrong. Just to give you a violation, specific violation. Okay. Coming up with such violations is very, very important. That's why it's not symmetric. But overall, okay, we have to actually check for not symmetric, and not symmetric is correct. That means this statement itself is correct because this says not symmetric. Then third case is neither transitive nor symmetric. Okay, so this one, mod x minus mod y is less than or equal, okay, sorry, which we saw it already, right? Now this is not symmetric, we already know. Is it transitive? Check for transitive. If mod x minus mod y less than or equal to 1 and mod y minus mod z less than or equal to 1, then mod x minus mod z is less than or equal to 1. That is what transitive says. Okay. Now, you can clearly see that that's not the case, because if you make it equal to 1, see, for example, if you say mod 7 minus mod 6 less than or equal to 1, correct. Mod 6 minus mod 5 less than or equal to 1, correct. Mod 7 minus mod 5 less than or equal to 1 is wrong. So not transitive, that is what you have to check. Not transitive is correct. So not transitive part is correct. That means overall option C itself is correct. So the only option left is D. We saw that D is symmetric is correct. What about D is transitive? Mod of x minus y is less than or equal to 1. Is it transitive? Okay, and the way you will check is, so if mod of and mod of y minus z less than or equal to 1, mod of x, is it true? Okay, this is the question. Okay, and you can easily check. Same thing, you can put mod of 6 minus 5, mod of 5 minus 4, mod of 6 minus 4, no. So transitive is wrong. Therefore, answer is option D. Okay, that is the not correct relation. Okay, quite a few people got it right. Good. Now we are going to move on to the third question, which I said is the trickiest question in this worksheet. Please go ahead and do question 3. Okay, if you are stuck with question 3 and unable to proceed, okay, then I will give you a hint. Otherwise, okay, just hint, let mod of greatest integer x be t, then you can write the given function as some root of t minus 2 by t minus 3. It's not f of t, we will call it some g of t. Okay, to find the domain of g of t, then you will get a condition on t, then you will get condition on greatest integer, mod of greatest integer x. Then you have to systematically solve it. Wow, quite a few people have got the right answer. Not bad. I thought this one was a very tricky question. I still think it's a very tricky question. Okay, so let me proceed with the method that I have outlined. Okay, so what is the domain of root of t minus 2 by t minus 3? See, this you have to be very careful. Okay, so t minus 2 by t minus 3 must be greater than or equal to 0, because whatever is inside the root must be greater than or equal to 0. So therefore, t minus 2 and t minus 3 greater than or equal to 0, or t minus 2, so both or t minus 2 less than 0, t minus 3 less than or equal to 0. Okay, that means t greater than or equal to 2, comma t greater than or equal to 3, which implies t greater than or equal to 3. This is t less than or equal to 2, t less than or equal to 3, which implies t less than or equal to 2. So finally, we want t greater than or equal to 3 or t less than or equal to 2. But t equal to 3 is not possible, because t equals 3 not allowed. As denominator will become 0. Therefore, solution or condition for t greater than 3 or t less than or equal to 2. Both are correct. So let's take case 1. This is 1 and this is 2. Okay, t greater than 3, which means greatest, sorry, what is t? T is nothing but mod of greatest integer x is greater than 3. Then what is the condition on, see, mod something is greater than 3. What does it mean? Okay, in general, mod x greater than 3, you should know this maybe as a separate thing. Mod x greater than 3 implies x greater than 3 is not correct. It's not complete. X is greater than 3 means yes, mod x will be greater than 3. Or x less than minus 3. Both are allowed. Okay. Therefore, in this particular case, instead of mod x, you have mod of greatest integer x. So therefore, greatest integer x greater than 3 or greatest integer x less than minus 3. So these are the two things that you get under case 1. So this is 1a and this is 1b. 1a says greatest integer x is greater than 3. So what values do you think x can be? X cannot be 3.5 because greatest integer of that will be 3 and you want greater than. So x belongs to 4 comma infinity. 4 is allowed. This is greatest integer x is less than minus 3. That means, can x be equal to minus 3? No. But can x be equal to minus 3.1? Yes, because that greatest integer is minus 4. So here x belongs to minus infinity comma minus 3 open interval. Okay. But this is not all. This is only case 1. And case 2 is still there. Case 2 says t less than or equal to 2. Again, remember, let's put one box like this. What does it mean to say mod x is less than or equal to 2? You can't say x is less than or equal to 2. Minus 5 is also less than or equal to 2, but mod minus 5 is not less than or equal to 2. So the correct answer is minus 2 less than or equal to x less than or equal to 2. On the real number line, mod x less than or equal to 2 means, okay, it's easy to understand it from the number line point of view. Okay, you put, so 0, this is 2, okay, and this is minus 2. All of these regions are allowed. In fact, in general, you can, this, I'm just giving, in case you encounter this, mod of x minus a less than or equal to b means the distance from x to a must be less than or equal to b. So start from a, whatever it is, and go till a plus b and a minus b. This will be the range. So you can think of this as x to a less than or equal to b on the number line. So from a you can go b on the right or b on the left. Distance means you can go either way. Okay. So here that means mod of greatest integer x is less than or equal to 2. Therefore minus 2 less than or equal to greatest integer x less than or equal to 2. Both have to be satisfied. Okay, that means greatest integer x can be minus 2, minus 1, 0, 1, 2. X can be what? See, x can be 2.7 also because that, so 3 is the maximum, but 3 is not allowed. On the negative side, can you x be minus 2? Yes. Can be minus 2.1? No, because that will become minus 3. But can it be minus 1.9? Yes, that is also minus 2, greatest integer. So it's minus 2 comma 3. This is the trickiest part. Getting this correct is, of course, given that the pattern is given, so you can see that A, so final answer. Okay, x belongs to what did we see? 4 comma minus infinity minus 3. So on the number line, minus infinity minus 3. So x belongs to this is one possibility. Okay, this is not counted, so I'm putting a circle. Then 4 comma infinity is there. 4 is included. Okay, so that is we saw, yeah, 4 is included. So I'll put a thick dot there. Then what else? And then minus 2 to 3. So this is minus 2, which is included, 3, which is not included, and this region is also included. Okay. So your A is minus 3, B is minus 2, C is 3, and therefore A plus B plus C is minus 2. 4 comma infinity didn't matter at all. Okay. Just keeping track of all the cases, etc. That is the tricky part in this question. It's not conceptually very hard. Okay. Okay. So we have done. So let's do one more question, and after that, we will pause for doubts. We won't have any break. Sorry, it's only a 2-hour class, so there's going to be no option for a break. Okay, more than 80%, 85 actually. I said just right, so I'm going to go with that place. One thing I want to tell you, if you have created summary sheets, feel free to use them to refer to the theory while you do the class. I'm a little tempted to say you can use my summary sheet, but that's not a good idea because you have not written it. You won't remember it. But if you have written something, feel free to use it during the class. Okay, even during the test, feel free to use it because this is not a test of your theory. This is a test of how you can apply it. I'm generally going to assume that the theory is something you will remember, especially if you prepared a summary sheet. I know Balaji has stressed on that a lot. Okay, it is very, very important. And it's important that you use it if you've created it. So feel free to use it both during the class as well as even during the practice test. We will not consider that as cheating. Okay. Few people have got it, but others are still struggling for question 4. Okay, quite a few people have got it, so let me proceed with the solution for question 4. So here, the first thing is we want onto function. So n of A is 7, n of B is 3. Onto means surjective functions. That means codomain equals set B. Function is from A to B. Okay. Now we are told that f of x is equal to y2 for 3 elements in A. So the number of ways picking these 3 elements is 7C3. Okay. See, one example, for example, is could be x1, x5, x6. Okay. Now, the remaining 4 elements are x2, x3, x4, x7. These have to be mapped to okay, y2 is already done. Exactly 3 elements is what it says. It's exactly 3, not at least 3, exactly 3. So these have to be mapped to y1 or y3. Not and, it's or. Each element can only be mapped to one of the elements in B. Okay, so number of ways is 2 into 2 into 2 into 2, which is 2 power 4, because each element you can choose either y1 or y3. But this is not all. But this includes one case where all 4 are mapped to y1, and this is not okay. Because why is this not okay? Because onto is violated. If you do everything to y1 and then y2 3 elements are there, y3 is not mapped at all. Onto means every element in B must be an image. So this is one case, all mapped to y1, and where all mapped to y3 is one case. Cases, all 4 x2, x3, x4, x1 are mapped to y1 or y3. So that means subtract 2. Therefore, number of acceptable mappings for x2, x3, x4, x7. Two y1, y3 is 16 minus 2, which is 14. So 7C3 ways of picking for y2 and 14 for the remaining. Therefore, total ways is 7C3 into 14, which is directly one of the options given in the questions. Option D is the right answer. Suhas Katokar has said in that question, he wrote it as t minus 2 by t minus 3 as 1 by 1 plus, no, wait. You're saying one by 1 plus 1 by t minus. Okay, it looks like it's t minus 2 minus 1. One plus 1 by t minus 3 seems to be wrong. Check this, Suhas. Okay, anonymous. In question 3, could you go through the two cases again and explain, anonymous? That is really unfair for the other students. See, you have to go back and see the video. That's the only way. This is a crash course. I cannot pause. I mean, the video is going to be available to you. You can go back and see. But I will not be able to go back over each solution because we have to finish 10 questions at least. Okay, so please let me know if there is any specific step which you are not able to follow. Then that I will clarify, because even if you see it again, you won't be able to follow it. But if overall a series of 7, 8 steps you want to do again, then that's going to be difficult. Hamsini Padmanabhan, you have asked specifically of case 2. See, please ask specific doubts. Case 2, t is less than or equal to 2, which implies mod of greatest integer x less than or equal to 2. And mod x less than or equal to 2 has this thing of minus 2 to 2. Why? Mod x less than or equal to 2 means x can be 1.5, 1.7, etc. minus 1.3 also, but not minus 5. So that's why minus 2 to 2. And this is in general. Okay, go back, think about it. You will be able to see it's correct. Okay. Pranav Nathan Sivakumar, I find it difficult to solve questions like question 3. I said that's the hardest question. If you get a question like this in JEE Main and you even leave it, I wouldn't blame you. It is worth sometimes leaving very hard questions. Okay. Advait also said difficulties in domain and range. That's why we are doing this practice. Okay. Now what I'm going to do is I'm going to try another thing where I'm going to give you 2 questions at a time, but I'll give you more time. Okay, so questions 5 and 6, they are similar. Okay, as in you have to do same kind of work. So doesn't So the advantage here is when I give only one question and only 3 4 minutes, there are many people who feel like if I had some extra time, I would have been able to finish the question. So I'm giving you that extra time. So instead of having two questions partially solved before I do the solution, you can at least have one question fully solved. And in fact, by the time I do that question, you can do the other one. Okay. So I'll give you like maybe 6 minutes or so. Okay. Please go ahead and solve question 5 and 6. Okay. End of the class, I'm going to ask you your preference by way of poll on whether you would prefer to have one question at a time or two questions at a time or a mix like what we are doing today. They both have their advantages and disadvantages. And in the past, I've tried both with students. Okay, this time I think the mentors have put one pop-up box for both questions. Okay, that means then only if you solve both you'll be able to answer, which I don't want. I want you to be able to solve even one. So next time we'll put separate boxes. Okay, in question 5, I think there's a small error. Okay, by now quite a few people have solved, in fact, both questions. This here the questions are not very difficult. That's why I gave them together. Okay, let's first look at question 5. How do we find the range of f? Okay, f of x is x by 1 plus x squared. So y is x by 1 plus x squared. X squared plus 1 into y is x. So you get a quadratic in y. Now, for x to be real, discriminant is greater than or equal to 0. So 1 minus 4y squared is greater than or equal to 0. So y squared less than or equal to 1 by 4. By the way, this is the same as, okay, y squared less than or equal to 1 by 4 is same as mod y less than or equal to half. Therefore, minus half less than or equal to half, less than or equal to y less than or equal to half. So just like we saw for mod, okay, why? Because y squared less than or equal to 1 by 4, you can write it as mod y square less than or equal to half square, and both are positive. So you can say mod y is less than or equal to half. Okay, because mod y is negative never makes sense. But mod y less than or equal to half means minus half less than or equal to y less than or equal to half. So whatever you're comfortable, whether it's square or mod, you can choose, but you're going to get the same kind of thing. This means y belongs to minus half half. Now that means the range. To find range, we always do y equals. This is the first step for finding range. Now I know that many of you would have missed one following trick. This whole notion of taking discriminant, okay, applies only in discriminant d greater than or equal to 0 makes sense only if yx squared minus x plus is a quadratic. This implies y not equal to 0, because if y is 0, it's not even a quadratic. Okay, so all this notion of discriminant etc. won't make sense. So therefore, should we say minus half to half minus 0? In fact, if that was one of the options, it would make sense. But that's not one of the options. Did JE make a mistake? Maybe sorry, which one? Just give me a moment. But did I say A and B are the same option? No. One is R minus minus half half, the other is minus half half. I thought it was the same option. Okay, but there is no minus half half minus 0. Okay, but even then, if y is 0, yes, it's not a quadratic, but don't assume automatically that y equals 0 is not allowed. Is y equals 0 allowed? So that means you have to ask the question, is 0 equals x by 1 plus x squared possible? And the answer is a resounding yes when x equals 0. Therefore, y equals 0 is part of range, though not because it's a quadratic. So the answer is the range is minus half to half. Okay, you try, just to check, you can also put some values. Put x is equal to 3. 3 by 1 plus 9, 3 by 10. 3 by 10 is 0.3, which is between minus half to half. If you're confused between A or B, it's very easy to check. Okay. Okay. Now let's move on to question 6. Okay. Here you have to find out whether the function is injective, surjective, etc. and what combination. Okay. So here A is x, x is not a positive integer. So x is all real numbers minus natural numbers. Positive integer means natural numbers. Okay. F of x is given as 2x by x minus 1. Okay. And f is from A to R. So injective condition is f of x1 equals f of x2 implies x1 equals x2. This is the question. Or you should ask, does f of imply this? If the answer is yes, then it's injective. If the answer is no, then it's not injective. So let's suppose f of x1 equals f of x2. That is 2x1 by x1 minus 1 is equal to 2x2 by x2 minus 1. Suppose this is true, then what you will find is 2x1 x2 minus 2x1. If you cross multiply, 2x1 x2 minus 2x2, and these two will cancel. So minus 2x1 is equal to minus 2x2, and minus 2 also can be cancelled because they are not 0. Therefore, you will get x1 is equal to x2. That means the answer is yes. If f of x1 equals f of x2, we get x1 equals x2. Therefore, function is injective. Okay. What about surjective? What is the range? So check. Is range equals codomain? Codomain is all real numbers. Okay. So is the range same as the codomain? So, for example, A is all elements where x is not a positive integer. See, suppose you find f of 3, okay, which is nothing but 2 into 3 by 3 minus 1, which is 6 by 2. Okay, that's, I will take 5. Nothing wrong with 3. I don't want an integer because that will confuse. So 10 by 4, which is 5 by 2. Now 5 by 2 is a perfectly fine, valid real number. Okay. Now, but 5 by 2 can't be part of range because phi is not part of domain, because domain has no integers, no positive integers. So if you have 2x by x minus 1 is equal to 5x by 2, sorry, is equal to 5 by 2, so you get 4x is equal to 5x minus 5. So x is equal to 5 is the only way. if you want, but x equals 5 is not allowed. That means the range is not equal to codomain. Okay, definitely range cannot be all real numbers. Therefore, not surjective. That means it's injective but not surjective, which is option A is the correct answer. Okay, I hope this is clear. Many people got it right. Now go ahead and do question 7 and 8. You can answer these separately. If you finish question 7 alone, answer that. My goal is to finish the class by 8:10 so that you can have the practice test from 8:10 to 8:30 or 8:15 to 8:30, 8:35. 15 to 20 minutes should be fine. You'll have 5 questions in the practice test. TVK Ishani has asked, there is a lot of theory in the Agro module books. Do we have to learn all of it? See, you should only remember those formulae that you can afford to remember. Okay, so you can, if you're already comfortable with whatever I've given and there is some extra stuff that you think you can add to your summary sheet, you can add that. But there's no point in just memorizing many formulae, because it's not just about the memorization part or derivation. The problem is, and it's not about whether you know how it is derived. The problem is, how many can you remember? So the short answer, TVK Shani, is no, you don't have to learn all of it. Okay, now question 7. Okay, we are writing f of x as a sum of an even function and odd function. And in fact, in the theory, both in class as well as in a summary sheet, I've given any function can be written as sum of even and odd function. And what I did not mention, and which I'm going to mention now, okay, is a very important point, which I'm going to mention now, which is that in a unique way, so that means there is only this one way of writing it as a sum of an even and odd function. And why is that important? Because here you are told that f of x is f1 plus f2, or f1 is even and f2 is odd. How? If there are multiple ways, how do you know which f1, which f2? And that is the proof is very simple. Suppose f of x is g of x plus h of x, where g is even, so g of minus x is g of x, and h is odd, h of minus x is minus h of x. So f of minus x is g of minus x plus h of minus x, which is g of x minus h of x. So if you just take equation 1 and 2, g of x is f of x plus f of minus x by 2, and similarly h of x is f of x minus f of x minus 2. We have derived the g and h. Here g is f1 and h is f2. Therefore f1 of x is f of x plus f of x, f of minus x by 2. So a power x plus a power minus x by 2, and f2 of x is a power x minus a power x by 2. minus a power minus x by 2. Now the question is, what is f1 of x plus y plus f1 of x minus y? f1 of x plus y, both are f1. A power x plus y minus a power minus of x plus y, the whole by 2, is a power x minus y, a power minus of x minus y, the whole by 2. So the sum of both minus of x plus y minus a power minus x minus y, the whole by 2. And this, you can write this as a power x, a power y, minus a power minus x, a power minus y, plus a power x, a power minus y, minus a power minus x, a power y, the whole by 2. Why do I write it like this? Because I want to take a power x common between these two. You get a power x into a power y minus a power minus y. And similarly, if you take a power minus x common between these two, okay, plus a power minus x into minus a power minus x, if you take common, you will get a power y. Oh, there's a mistake somewhere. Wait. Sorry, f1 is plus everywhere. Sorry, I made a mistake. It's plus everywhere. So it's a power y plus a power minus y. My bad. Okay, plus a power minus x into a power y plus a power minus y. Everything is plus. So it's a power x plus a power minus x. Now, why do I write it like this? Why do we write like this as product of factors? Why are we obsessed with that? Because answer options all have products. That's the only reason. It's not like suddenly we are very fond of joblessly factorizing expressions. Okay? We would have been perfectly content with leaving it as a power x plus y plus a power minus of x plus y, etc. But that's not the form in which the answer options are there. So you will have to write it as some product to see if you can get it in some of those things. So this you can write as 2 into a power x plus a power minus x by 2 into a power y plus a power minus y by 2, which is nothing but 2 f1 of x, f1 of y. Both are f1, and the correct answer is option A. Yeah, f1 is the even function. I used the odd thing by mistake. Siddhartha Raghavan, yes. Srihari also and pointed out the same. Very good, thank you. I corrected it immediately after some time. Okay, that was question 7. Now let's move to question 8. Question 8 is also a little tricky. Okay, and you have to follow very carefully about this odd and even business. Okay, and you are asked whether it's injective, surjective, etc. Okay, so first let's find g of n. G of n is equal to n minus minus 1 power n. So let's find g of 1. Both are from natural to natural. 1 minus minus 1 power 1, which is 2. G of 2 is 2 minus minus 1 squared, which is 1. G of 3 is 3 minus minus 1 power 3, which is 4. And g of 4 is 4 minus minus 1 power 4, which is 3. So you can see this pattern. So g of n, when n is odd, n plus 1 when n is odd, and n minus 1 when n is even. Okay, this much should be pretty straightforward. Okay, but why do we write it like this? Because we want to know, okay, do we want to know whether n is odd or even? No. Actually, what we want, f of n is n plus 1 by 2 when n is odd, n by 2 when n is even. What we want in the question is f of g. So you might think f of g of n, you might think, okay, put two cases for n is odd and n is even. No, it's f of g of n. So it is g of n plus 1 by 2 when g of n is odd. Remember, instead of n, you put g of n. And g of n by 2 when g of n is even. The problem is, this is not about n. This is about whether g of n is odd or this thing. That actually is, when n is odd, g of n is even. And when n is even, g of n is odd. So when is g of n n plus 1? When n is odd. But also when g of n is even, it is n plus 1. So here we can beautifully replace this as, so g of n being odd is the same as this. That means g of n itself is n minus 1. So n minus 1 plus 1 by 2 when n is even. G of n is odd when n is even. Okay, g of n is even means you go to this case. If g of n is even, g of n is n plus 1 and n is odd. So n plus 1 by 2 when n is odd. So we have defined f of g of n when n is odd and n is even. In fact, what is this f of g of n? It is simply n by 2 when n is even, n plus 1 by 2 when n is odd, and you can confirm that in both cases it will return a natural number. If it was the other way around, n by 2 when n is odd, then f of g of 3 will be 3 by 2. 3 by 2 cannot be part of the range, and that's an indication that you have made a mistake somewhere. But now it's easy. So let h be f of g. So h of 1 is 1 plus 1 by 2, which is 1. H of 2 is 2 by 2, which is 1. H of 3 is 2. H of 4 is also 2. H of 5 equals H of 6 will be 3. H of 7 is equal to H of 8 is equal to 4, and so on. So you can see that clearly, okay, or I hope it is clear, H is not injective because you have H of 1 equals H of 2 and 1 is clearly not equal to 2. So two numbers, 1 and 2, give the same image 1. Two numbers give the same image 2. Two numbers give the same image 3. So clearly not injective. And it is Subjective because codomain is, sorry, range is all natural numbers, not codomain. Range. Because you see, h of x is equal to 1, 2, 3, 4, everything is possible. So the range is all natural numbers. That's the beauty. So the correct answer is, it is not on 2 but not 1, 1. So the correct answer is option B. Okay, so we have finished till question 8. For every 4 questions, I'm asking you to, I'm checking whether you have any doubts. 9 and 10 we'll do separately, because I think doing both questions together might be a little tricky. Okay, please go ahead and do question 9. Suhas Katopar, still it doesn't seem like correct. T minus 3 plus 1 is t minus 2. Okay. T not equal to 3 you will get. Then you will get, no, you don't lose any case. You will get 1 plus 1 by t minus 3 is greater than or equal to 0. So 1 by t minus 3 is greater than or equal to minus 1. So you have to consider 2 cases. So both, you will still get all the same cases. You will not lose any case just because of writing like that. Okay, Sri Charan Meduri has asked, what if you get in JE a question that's easy but very lengthy? Do we solve it? See, that depends on you. If you think it is easy, then you will mark it for the first attempt. And I would say if you marked it as easy, go ahead. Whether it's very lengthy or not, you'll know only when doing. And if you've already done like 50-60%, no point in this thing. See, as long as you know what to do and you're clear, it's just taking more than average time, it's fine. If you don't know what to do, if you're like, so those things I'll come to when we talk of time management for the exam. Right now, I don't want to go in too much into this. Okay, it's your call. But if you have marked it as easy, then go ahead and do it. If you see that the number of tests is so much that it will be difficult, then mark it as medium or difficult. Come to it in the second round. Is it okay to solve questions without much steps and logic? In JEE, we don't care about your steps. But if you don't solve without the steps and logic, what if you get it wrong? Srihari has asked a good question. For conic sections, tangents and normals is deleted portions for right. So how do you practice the remaining? We will give you questions only on the basic part. Okay, don't worry. I will give you questions. For the crash course, we have decided that we'll only give you mains portion questions. Okay, at least in my this thing. Now, the theory we have given other things because for advance is required, and we did a poll and we asked the students also, right? Remember that. But for the crash course, I'm only going to give you mains questions. That means 3D geometry, no planes. Okay, and Sri Charan, one of the questions you asked is it okay to have only formula in the summary sheet? No, you must also put types of questions. Anonymous has asked, the fifth question, I still don't understand why 0 shouldn't be excluded as it is making the x non-real. No. Y equals 0 gives x equals 0 as a real solution. It is not a non-real solution. Think about it. Y is equal to 1x by 1 plus x squared, correct? If I'm not mistaken. In question 5. Implies x equals 0. You can't solve it as a quadratic. See, this is what you mean. What you are saying is yx squared minus x plus y equals 0. Y is equal to 1 plus or minus root 1 minus 4y squared by 2y. So not y is equal to x is equal to. This has no solution for y equals 0. So the quadratic has no solution for y equals 0, but it's not even a quadratic when y equals 0. The quadratic is invalid. But it's invalid as a quadratic. Actually, I should have put this 2y in the denominator and said that's why it's not allowed. If y is 0, you get x is undefined. But that's only because you were taking it to be a quadratic. It's invalid as a quadratic if y equals 0. But practically, you can solve for x as x equals 0 and y equals 0. So that's the nuance in that question 5. It's a very tricky idea. Okay. And Anonymous has also asked in question 6, we can use first derivative method. How will you find first derivative? No. First derivative is for maxima and minima. Here you are trying to do range. That will work only if your domain is all real. Yeah, you can find the range maximum. But see, you may not be able to find maximum and minimum using first derivative all the time. Okay, for question 9, many people have given the answer. Okay, if you finish question 9, you can go ahead and do question 10. You don't have to wait for my solution. If you got the right answer, you can go ahead and do question 10. So here, it's very important that the f is given as from r minus 3 to r minus 1. And the reason is, if you put y equals x minus 2 by x minus 3, this is anyway necessary. First of all, x not equal to 3, so this part is correct. Okay, but why is y not equal to 1? Because you will solve for x as 3y minus 2 by y minus 1. And when y equals 1, x is undefined. So y equals 1 is not part of the range. That's why this part is correct. Okay, but why did we have to write this x in terms of y? Because that's anyway required for inverse. Okay, therefore f inverse x is 3x minus 2 by x minus 1. You may think f inverse y is 3y minus 2 by y minus 1. But that's correct. F inverse x is therefore 3x minus 2 by x minus 1. Okay. Now, g of x is 2x minus 3. So, x is equal to y plus 3 by 2. So, g inverse x is x plus 3 by 2. So, f inverse x plus g inverse x is equal to 13 by 2, implies 3x minus 2 by x minus 1 plus x plus 3 by 2 is 13 by 2. Okay, so this, if you simplify, you get 2 into 3x minus 2, x minus 1 into x plus 3 by 2 into x minus 1 is 13 by 2. So 13x minus 13, 6x minus 4 plus x squared plus 2x minus 3. So finally you get x squared minus 5x plus 6 equals 0. X is 2 or 3. So sum of all values of x is equal to 5. Okay. Please go ahead and do question 10, which is the last question for today. After this, you will have a test. Practice test for, like I said, try and do it within 15 minutes, but probably 20 minutes can be given maximum. So here you have f of, etc. You have to understand that f100 means you have to use that fn plus 1 x definition. Okay, quite a few people have got this right. Okay, so what is fn plus 1 of x? Is f naught of fn of x. So f2 of x, sorry, f1 of x is equal to f naught of x. F naught of x is given as 1 by 1 minus x. 1 by 1 minus 1 by 1 minus x, which is nothing but 1 minus x by minus x, which is nothing but x minus 1 by x. This is f1 of x. f2 of x is f naught of f1 of x is 1 by 1 minus x minus 1 by x. So this is simply x. f2 of x is simply x. So f3 is f naught of f2, which is f naught x. So you will find that f k plus 3 of x is fk of x. f0 is f3, f1 is f4, f2 is f5. Okay, again f3 is f6, which is the same as f0. Okay, so now with this idea, okay, so that means f3 is f naught, f, or f, you can write f naught is f3, f6, etc. f1 is, sorry, f4, f7, etc. and f2 is f5, f8, etc. So f100 is nothing but f1. So f100 you can see is 1 plus a multiple of 3 is f1 of x, and f1 of x we already found to be x minus 1 by x. Okay, so you have f100 of 1 of 3 is 3 minus 1 by 3, which is 2 by 3. Okay, f1 of 2 by 3 is nothing but 2 by 3 minus 1 by 2 by 3 minus 1 by 3 by 2 by 3, which is minus 1 by 2. And finally, f2 of 3 by 2, remember f2 of x, okay, is x itself. f2 of x is x. So 3 by 2. So the sum is 2 by 3 minus 1 by 2 plus 3 by 2. Okay, so this is 1 by 6 plus 3 by 2, which is 10 by 6, which is 5 by 3 is the answer. Okay, I hope this was useful. Okay, okay, the test will start in another 2 minutes. For that, let me quickly get your poll preference. regarding the number of questions to give at one shot. Okay, the class is over. The test will start in 1 or 2 minutes. It will be for about 20 minutes maximum. Okay, so all the best for the test. I'm sure you will do well. Okay, and I told you already, you can refer to your summary sheets while solving the questions. So that's perfectly fine. Okay. Okay, let me just quickly check whether the mentor is giving you this poll. If not, yeah. Okay, I think the majority have preferred like today's class, which is a mix of only one question or only two, and sometimes two questions. Okay, so I'll see. Okay, anyway, all the best with the test. It's going to start now. Okay, good night.